everyone. Okay, okay, good morning, everyone. Uh, Myself, Surun Sukla, and today we are going to discuss one of the important concepts related with the parsing. So, as we all know that in top-down parsing, we start with processing the string from the start symbol of the grammar. So, in order to doing this process, we get some kind of difficulty if our grammar is not in a written in a well format. So, before perform top-down parsing, we try to ensure that our grammar doesn't have these type of productions. Your grammar does not have ambiguity, so if it has, you have to remove that ambiguity. Similarly, if your grammar have left recursion, you have to eliminate that. And similar for the left right thing. So today we are going to understand the concept of left recursion. So what we mean by the left recursion, or if we talk about the objective of today's class. So first is what do we mean by do we mean by left recursion? Second, how it can impact our top-down parsing. And then how to eliminate left recursion from your grammar. So, before this, if you want to check out about the ambiguity, you can go to another video tutorial uploaded by me. Now, let's start discussing our today's concept, which is left recursion. So now, first of all, understand what is the definition of left recursion. So, definition of left recursion says that a grammar is said to be in left recursive if it is of the form, considering true production only over here. If it is a form of, let me write complete production set over here. If your grammar is in the form of A tends to A alpha or beta. So here alpha and beta both are just combination of terminals and non-terminals. So these two things are basically any combination of terminal and non-terminal. The only thing here is that the first symbol of your production is the same non-terminal that for which you are writing a production. So they are basically now considering this fact, there are basically two types of left recursion are possible. One is the direct recursion. So this is an example of direct recursion, and similarly, there is another type of recursion can be, which is indirect recursion. Indirect recursion means we are deriving from A to some another non-terminal B followed by some set of terminal and non-terminal symbols, and this B production is again deriving A followed by some beta symbols. So here we are basically now moving from A to B and then from B to A. So again we are achieving the resultant of these two production. If you substitute these two things, will be like this: A beta gamma. So again we are getting some left recursion over here. So this type of recursion is known as indirect left recursion. So the objective here is just to eliminate this left recursion and make your grammar from left recursive to right recursive. Now why we are doing this means how this left recursion is going to impact our parsing process. So just To understand this, let's consider an example over here. Let's suppose our production is A, B, and this A is terminated by some symbol C. And we are considering a string W, which is nothing but C, B, B, B. Now, when top-down parser start processing, it starts with the star symbol, then goes to the uh, right side of the projection. So here it has two choices. One is AB and another is C. So let's suppose it applies C over here. Then it will consume this input at first, and after that it will have three remaining elements B, B, and P. Now, since in parsing we can have one look ahead, one symbol look ahead in general. So this is going to create a problem for this. Another issue with this is that if you are going to apply this A tends to AB. Now, the choice is again whether you are going to expand this with C or you are again going to expand this next AB like this. So this can be hurdle to top-down parser because it is not able to identify whether this A needs to be terminated or to be replaced by the same left recursive production. So this kind of scenario creates a problem with your top-down parsing, and this problem is known as infinite recursion. This problem is known as infinite recursion. So, in order to avoid this and performing our top-down parsing very well, we eliminate left recursion first, then go for top-down parsing. So, just uh, let's check how to eliminate this left recursion from the ground. Let me clean this and rub all those things over here. Let me just mark this again to production. So to make this grammar, make this free from left recursion, we basically do make this grammar right recursive. So how we can make this right recursive? So in place of these two productions, we can add a new production with new non-terminal symbols. Like this, A is deriving beta A dash. Here we are introducing a new symbol A dash, and then this A dash will derive alpha followed by this A dash, and at the end we are going to terminate this A dash with null symbol or empty symbol. So the replacement of this left recursive graph. So now just consider. So now just considering example for this. So let's suppose our given grammar is S tends to SA, SP, A, and B. So in this case, we can see that this is of the form A, alpha 1, A, alpha 2, beta 1, and beta. So we can eliminate left recursion from this grammar and can produce symbols like this. S tends to A S dash, B S dash, and this S dash is deriving A S dash, B S dash, none. So this will be your final resultant grammar. So from this, you can see the general form of this left recursive grammar as well. So general form of left recursive grammar is A is deriving A alpha 1, A alpha 2 up to A alpha n beta 1, beta 2 up to beta n. Then the elimination of these two will be like this. A will derive beta 1 A dash, beta 2 A dash up to beta n, beta m A dash. Similarly, A dash will have alpha 1 A dash, alpha 2 A dash up to alpha n A dash and none. Okay, I hope this example is clear to all of you. And